Okay, this is lecture 33 of basic calculus 1. So, as you remember, we were discussing about how to compute volumes of solids of revolution. So, basically there is only one method we discussed, which is the slice method, and then a modification of it came when it is a solid of revolution to give the disk method. So, in this disk method, when you apply, our condition is that the axis of revolution should be bordering the region which is being revolved to get the solid. Suppose the line which is the axis of revolution is not bordering it or even not crossing it, then what to do? So, today we will be discussing that, and that is called washer method. So, here let us take an example. Say we have this region which is painted blue in the first picture. This is being revolved around the x axis, as this symbol says. So, now when it revolves, you would not get a solid without any holes, right. There will be a solid with holes, as you see in the second picture. Then when you take a slice, that will not be a disc, but a punctured one, it is an annulus. So, that is what we say, if the region we revolve to generate a solid does not border on or cross the axis of revolution, then the solid has a hole in it, and the cross sections perpendicular to the axis of revolution will be annular, right. So, they will be washers instead of discs. So, as earlier you can see that you can compute the volume of the total along with the hole and then subtract the hole from it. So, finally, what amounts to is that in the integral a to b a x, which is the area of the disc, now will be area of the washer, right. So, that will be total area of the disc minus the inside circle, inside area of the disc. So, that is what will be, and once you see that the area of that cross section a x, you take the total first. So, total will be, say, its radius from the axis of revolution to that point is capital R x, and the inside disc is having radius as small r x. Then this area will be pi times capital R x square minus small r x square. So, that is really the slice, area of the slice. Then it will be integrated to get us the volume. That is what exactly we do. So, if the outer radius of the washer is r x, capital R x, which is measured from the axis, and the inner radius is small r x, then the volume of the solid of revolution with that hole will be integral a to b. A to b are the limits of that region. Okay. So, a to b pi times r x square minus small r x square, and that is to be integrated with respect to x. And you may have also solid of revolution when the region is revolved around y axis. So, in that case you have to express this region as a function of y. So, it will be a y, and similarly the limits and then a y dy. We will come to it shortly. So, let us apply this washer method on an example. So, here the region bounded by the curve y equal to x square plus 1. So, it is this region, it is a parabola y equal to x square plus 1, and the line y equal to minus x plus 3, the blue one. So, they first of all they make a region, right, the region bounded by these two curves. So, that means it is assumed that they intersect somewhere at 2 points, and then a region is formed, and this region is revolved about the x axis. So, this is revolved about the x axis, that is how you get the solid. Now, you want to find the volume of the solid. So, as you see, we must find out first the capital R x, then small r x, and we should find the limits of the integration. which will come from the intersection points. So, let us look around it. The outer radius of the washer is r x is minus x plus 3, is that right? Because this line is y equal to minus x plus 3. So, the whole height taking from 0 to that place, that is your r of x, that is equal to minus x plus 3. And then the inner radius is the one which is not given here, right. So, that will be bounding, that will be measured from the x axis to that point on the curve. So, again that is point on the curve is x square plus 1. So, r of x is x square plus 1, that height, right. So, capital R x is minus x plus 3, small r x is x square plus 1. Then to find the limits of integration, we must find the region. So, the region is bounded by these two curves, that is their points of intersection would give us the limits of integration, the x coordinates of that. So, we have y equal to x square plus 1 and y equal to minus x plus 3, we find their points of intersection. So, eliminating y, we equate x square plus 1 equal to minus x plus 3, that gives you x square plus x minus 2 equal to 0. And we can factorize it, that is x square plus 2x minus x minus 2. So, that gives you x times x plus 2x minus 1 times x plus 2. So, it is x plus 2 times x minus 1, and that is to be set to 0 to find the points of intersection. So, that gives you 2 points minus 2 and 1. So, that corresponds to this point which is x equal to minus 2 and this point which is x equal to 1. So, we have got the limits of integration, we have capital R x, we have small r x, thus the volume is minus 2 to 1 integral of the slice, that slice is now a washer. So, that is pi times r x square minus small r x square. So, this is minus x plus 3 square minus x square plus 1 square. Now, you expand it. So, you get after expansion you integrate. So, let us see what is its expansion. It is x square plus 9 minus 6 x, and here it is minus x fourth and then minus 2 x square and minus 1. So, that gives us 9 minus 1 is 8, and then in x we have minus 6 x. So, it is minus 6 x, and then squares we have minus x square, and then fourth power which is minus x fourth. So, when you integrate you get 8 x minus 6 x gives minus 3 x square, minus x square gives minus x cubed by 3, and minus x fourth gives minus x fifth by 5. So, this multiplied by pi and is to be evaluated at minus 2 and 1 and subtracted out. So, that simplifies to 117 pi divided by 5. So, this is how we are going to solve problems or applying washer method, but this is applicable only when you will have a hole in it and the line of or the axis of revolution is not bordering the region. Okay, so, let us take another example. Here the region is bounded by the parabola y equal to x square, which is this one y equal to x square, and the line y equal to 2x, which is this one in the first quadrant, and this is revolved about the y axis. So, that is why this symbol to generate a solid. So, the solid is painted green here. Find the volume of the solid. So, again what we have to do, we should find out the outer radius, inner radius and limits of integration. Now, this is revolved around y axis. So, we should express the region as a function of y, that is we should find out the outer radius in terms of y, inner radius in terms of y, and then the limits of integration should be limits for y. Okay. So, as you see we have the curve as y equal to x square, or in the first quadrant we can write x equal to square root of y. So, you take any point x here, but we want it is revolved around y. So, you start with y. So, corresponding to that we have the outer radius as this full red line, and then inner radius is this curvy line, that length. So, that binds us to from y x equal to 0 or the y axis to the line, okay, y equal to 2x. So, that gives us the coordinate as when it is y, this will be y divided by 2, because x equal to y divided by 2. Okay. So, that gives this length, and the outer radius is of course square root of y. So, you get square root of y as the outer radius, y divided by 2 as the inner radius. Then we should get the points of intersection, and we have to solve it for y. So, we should eliminate x, that is we have x is square root of y, and the other side it is y divided by 2. So, that gives us one is y equal to 0, another is y equal to 4, right, root y equal to 2. So, y equal to 4. So, we have the limits as 0 and 4, fine. Then we have the volume which is 0 to 4 pi times outer radius which is root y square minus small radius which is y by 2 square. So, pi into y minus y square by 4 dy, and we simplify to get that it is equal to 8 pi by 3. This is pretty straightforward to apply. Let us take one more example. So, here we want to find the volume of the solid generated by revolving the shaded region about x axis. So, this is rotated this way about x axis and the shaded region only. So, the shaded region is given through the functions y equal to root cosine of x, okay, which is this blue curve, and of course, we want only okay, the shaded region also, that is also another line which is y equal to 1, that is the region lies between y equal to root cos x and y equal to 1. So, that is the blue region which is shaded here. And what are the limits? Of course, you can find the limits, but it is already given that x is minus pi by 2, y is pi by 2, and it is revolving around x axis. So, you need the limits for x. Then it is straightforward to write the volume, okay, where the limits will be minus pi by 2 to pi by 2, and outer radius and inner radius we have to find. So, here outer radius is really 1, the whole thing, and the inner radius you take any x. So, at that x you have the outer radius as 1 and the inner radius is this length, which is root of cosine x. Therefore, it is pi into 1 minus square root of cos x square. So, that gives 1 minus cos x dx. And now, we integrate. So, that gives okay, this is an even function. So, instead of minus pi by 2 to pi by 2, we write 2 times that, and there is a pi. So, that goes out 2 pi times 0 to pi by 2, 1 minus cos x dx. So, 1 as integral as x and cos x as sin x. So, x minus sin x evaluated at 0 and pi by 2. So, that simplifies to pi square minus 2 pi. So, once the things are given this way instead of a story, it becomes easier because the limits of integration are known. But this could have been reformulated some other way, and you have to find out what are exactly the limits of integration and what are these r x and small r x. Okay. So, let us take one problem. We want to find the volume of the solid generated by revolving the region bounded by the line y equal to 2 minus x and the curve y equal to 4 minus x square about the x axis. So, first thing is we have the region which is bounded by y equal to 2 minus x, y equal to 4 minus x square. We should get the region first, and then of course, the limits of integration will come from the intersection of those two curves. So, suppose you take the intersection, we would get say eliminating y, this is about x axis. So, you get limits for x. Eliminating y, we get 2 minus x equal to 4 minus x square, or that gives x square minus x minus 2 equal to 0. Okay. So, that means you can take say x square minus 2x and plus x minus 2. So, you can factorize now, it is x into x minus 2 plus 1 into x minus 2, or x minus 2 into x plus 1 equal to 0. That gives us the points as x equal to 2 and x equal to minus 1. So, in the picture, that is what it is done. The region is drawn here, where the first point corresponds to x equal to minus 1 and the second one here on the x axis corresponds to x equal to 2. Once x equal to 2, of course, y is 0. That is why it is on the x axis. Now, this region is revolved about the x axis. So, once it is revolved about the x axis, okay, our outer radius at any point x will be the big one. So, that is coming from y equal to 4 minus x square, and the inner radius is by the straight line. So, that will be y equal to 2 minus x. So, then our volume will be integral minus 1 to 2 pi times r x square minus r x square, which is 5 times 4 minus x square minus 2 minus x squared. So, we write this as 16 minus 8 x square plus x fourth minus 4 minus 4 x plus x square, that simplifies to 12 x plus 2 x square minus 3 x cubed plus x 5 by 5 after integration. Okay. So, you can verify 16 minus 4 is 12, and we have one x which is 4 x, and this is minus 8 x square minus x. So, minus 9 x square plus x fourth. Now, when you integrate, you would get 12 x, and 4 x is giving 2 x square minus 9 x square. So, that gives divided by 3 x cubed, and x fourth gives x fifth by 5. So, that is to be evaluated at minus 1 and 2, then subtracted, that simplifies to 108 by 5 times pi. So, it is crucial to see how the picture looks like sometimes. So, that this whole is to be subtracted out, and exactly the points of intersection, of course, that can be obtained algebraically, but the plotting of that gives a better feeling and minimizes mistakes. Okay. So, let us take the next problem. Here we want to find the volume of the solid generated by revolving the region in the first quadrant. So, we have the region in the first quadrant, bounded on the left by the circle x square plus y square equal to 3, and on the right by the line x equal to root 3, and above by the line y equal to root 3 about the y axis. So, first we have to see what is the region, then think about revolving it about y axis. So, getting the limits for y from the intersections, and then find capital R x, small r x, plug it in the formula. So, if you plot it, first thing is it is the region in the first quadrant, bounded on the left by the circle x square plus y square equal to 3. So, in the first quadrant we draw the circle x square plus y square equal to 3. It is not up to scale here, y looks a bit more height it should have been here. Okay. So, x square plus y square equal to 3, that is the portion of the circle in the first quadrant. So, you get the points on the x axis as root 3, where y is 0, and on the y axis where x is 0, y is also root 3. So, these are the points of intersection with the axis of the circle. So, this region is bounded on the left by the circle, and on the right by the line x equal to root 3. So, this is the line x equal to root 3, and above by the line y equal to root 3. So, it is this line, and this region is to be revolved about the y axis. So, it would go this way, it is revolved about the y axis. Okay. So, since it is revolved about the y axis, you take any point on the y axis, say y, corresponding to it what is the outer radius, what is the inner radius, for obtaining this region when it is revolved around. It is the outer and inner radius of the washer. So, for the washer now, you have the outer radius as the whole thing, which is equal to, of course, at y. So, it would go up to this, that is again root 3, and the inner radius will be up to this point. So, that is on the circle x square plus y square equal to 3, or you get the x equal to, that length is on the x axis we are measuring. So, x equal to square root of 3 minus y square, that should be our inner radius. And what are the limits? The limits for y are clearly it is 0 and then root 3, that describes the region. So, we have r y equal to root 3, small r y equal to square root of 3 minus y square, and volume equal to 0 to root 3, it is 0 to root 3 in the y axis, pi times r y square minus small r y square dy. So, now r of y, capital R of y is root 3. So, it is 3 minus small r y is square root of 3 minus y square. So, it is 3 minus y square. So, that gives to pi into integral 0 to root 3 of y square, that simplifies to y square, which is y cubed by 3 evaluated at 0 and root 3. So, that gives pi times root 3. Okay. So, initially when you see the story or the statement of the problem, it was not obvious how to go about it, but once you plot it, then the things becomes easier.